Welcome to Corrosion Coach. Let's get you started with another practice. In today's practice, we're going to talk about galvanic cathodic protection. Now understand, there's a couple different primary systems that you can have when you need CP. Something called galvanic, which we're going to talk about in this slide deck, and something called impressed, which is going to be for another video. At a high level, what you need to know is for the galvanic systems, you do not have to have external power to operate those systems or to run those systems. When I talk about external power, I'm talking about commercial AC power, I'm talking about solar, talking about electric generators, things like that. With impressed, you do have to have that. So no power required for GCPs. A couple other pros, of course there's some cons, are along with no external power is the installation cost of a galvanic CP system is pretty cheap, especially if you compare it to the installation cost of an impressed system, a rectifier, a deep type ground bed, things like that, and certainly solar. That's all good stuff, but it's high dollar to install, high dollar to purchase or procure. So again, low cost when compared to that. And then the maintenance cost is also overall going to be cheaper when you compare to an impressed system. I've got much less parts and pieces associated with a GCP. It's a lot more simple than compared to an impressed system. And what's the downside? So the downside is going to be my current output is not going to be very much. So if I've got a large pipe system, gathering system, long line transmission, certainly a poorly coated system, I'm probably not going to be able to go with a galvanic system. I've got low current output, so if I need a lot of cathodic protection current or DC current, I've got to go with an impressed system in most cases. So that can be a disadvantage. And then my driving potential is going to be low as well. Think of your energy, think of volts or potential difference. If I'm up in the mountains of Arkansas, let's just say, where I've got high soil, I need a lot of volts to get the current. Just think of Ohm's law. So I may only be operating with half a volt, something like that. Where in the mountains, I might need a 50 volt system or an 80 volt system, maybe even a 100 volt system. So again, my driving potential is going to be low with galvanic. That's a disadvantage. But in low soil environments, I can certainly get away with it. So what we're doing here, I'm going to walk you through this a little bit. I've got my pipeline over here buried. I've got a cable connected through a test station. You can see my little squiggly line there that's supposed to represent a shunt. A shunt is nothing but a known resistor. I've got the other part of that cabling connected to what I've buried is a magnesium anode. And so I really don't want corrosion to happen on my pipeline. So instead, I've buried this magnesium anode to corrode on behalf of. And so we're going to have current discharge off of this magnesium anode. It's going to go through the earth or electrolyte, and it's going to collect on our pipe. And then it's going to use this cable for that current to travel up the test head, across the shunt or known resistor, down this cabling back to the anode, and round we go. And so the corrosion, remember, where current discharges off of a metal through the electrolyte, it takes metal with it. And so that where it discharges is where it's going to corrode. So the magnesium will corrode. Where current collects, it actually protects it. That becomes the cathode, hence cathodic protection, and round we go. Now, I buried magnesium. I chose that on purpose. Why did the current discharge off the magnesium? Well, it's because we whispered to the magnesium before we buried it to make sure. No, that's not true at all. So let's go back to that practical galvanic series. Some metals have higher energy levels than other metals. The metals with higher energy will always corrode when you couple it to protect the lower energy metal. And so that's what we're showing you. We've got another video dedicated just to galvanic series here. But I'm showing it to you again because it plays a critical part in this. And so we've got magnesium at the top of this list here. It's a very negative voltage measurement or an open circuit potential. It's very active. It's got a lot of energy. And so magnesium, if I couple that with steel, it's going to corrode to protect that steel. So I want my steel to become my cathode. Steel is down here kind of in the middle of this particular table. And then I'm going to connect it to that magnesium, which is what I showed you in the slide before. The magnesium will corrode to protect my steel, which is nice. That is an example of galvanic cathodic protection. Because of the voltage difference of the magnesium and compared to the steel, it's like a battery, which is something that I think you've seen before. You use it all the time. A battery is nothing but a galvanic CP system. Okay, didn't know that. I certainly didn't back in the day. Well, let's take a look at that battery. Remember, we need 4 components to have corrosion: anode, cathode, electrolyte, and metallic path. So let's see if we can identify that in this particular setup here on this battery. So in the middle, we've got a carbon rod. That's a metal. We've got a backfill, and we've got a paste that acts like an electrolyte. Okay, so there's my electrolyte. And then I've got a zinc case. So the 2 metals I'm dealing with here is carbon and zinc, and I've got an electrolyte. Well, what's the metallic path? That 4th thing necessary to have corrosion. It's when you click the button on the flashlight, it connects the positive to the negative, and now I have light coming out of that flashlight utilizing this battery. So carbon and zinc, I want you to remember that. Going back to this table, let's get a highlighter here. And so my highlighter, I'm going to highlight carbon in blue. That's a very noble metal. It does not have a lot of energy. And then let's highlight the other metal, which was zinc, which is up here. Okay, that's an active metal. And then I'll get my pen there. And I'm going to couple zinc with carbon through a metallic path. I'm going to put it in an electrolyte, and because the zinc is more active, it's going to corrode to protect this more noble metal, which is why that battery works. Going back to the battery, there's your carbon, there's your zinc, which is the case itself, and then the backfill is in there. The electrolyte is inside the battery. The metallic path is when we click the button from positive to negative, and we now have light in our flashlight. So there's your battery there. Some of the common metals that we'll use for galvanic CP systems, we already talked about zinc. Aluminum would be another one. I'm sorry, we already talked about magnesium. Aluminum would be another one, and then zinc showed up in that battery. So again, going back to the galvanic series, I'll just highlight those to make it a little easier for those of you that are looking at this on your phone there. So we've got magnesium, we've got zinc, and we've got aluminum. And again, typically we are protecting steel, which is in the middle of this particular galvanic series. So galvanic cathodic protection is nothing but understanding the galvanic series. The more active metal is going to corrode to protect the more noble metal. So that's it. Galvanic cathodic protection. We'll talk about impressed current cathodic protection in another video. You now have more knowledge than you did. I think you're ready for game time. Appreciate you. Have a good one. I'm your corrosion coach, Adam Johnston. We'll see you.